Hello, today we are going to cover 8.3 graph rational functions. You guys will be able to identify properties of rational functions and graph rational functions. So we have the form of a rational function. This is y equals a over x minus h plus k. This might be slightly recognizable from having a, h, and k in parabolic, the quadratic functions, as well as absolute value functions and things like that. Okay, so the different letters can tell us things. We are going to start with A. So I'm going to actually just draw an example of this so that way we can see it versus trying to have words. So in rational functions, we have something called asymptotes, which we'll get to how to find those in just a little bit. But for this example, they are just this dashed line. If our A value is positive, our graph will look something like this. It will never touch the asymptote line. It'll just come very close to it and turn. So notice for A being positive, our graph is in the top right and bottom left quadrants of our asymptote. For A being a negative, this changes a little bit. The asymptotes can be in the same spot, but the graph will change. We will have the top left and the bottom right instead. So notice how they look different just based on the positive or negative of A. Asymptotes, we have a vertical asymptote. That would be this guy and this guy. A vertical line. How do we find that? So for vertical, we want to look at the value that makes the denominator 0. And this will be an x equals equation that you can graph, okay? So I'll get to an example in just a minute. For horizontal, we need to define something real quick. We are going to, let me write this out. There we go. For horizontal, we are going to compare the degrees of the numerator and the denominator. We are going to call the numerator m for this case, so that way we don't have to write out numerator and denominator all the time. And the denominator is n. Okay? So then, we have 3 comparison cases. We have when m, the numerator, is smaller than n, the denominator. This is y equals 0, or your k value will be your horizontal asymptote. You could have when m is greater than n. This is when we have no horizontal asymptote. Or you could have m equal to n, which we'll look at an example of in just a minute. And this is y equals a over b. So we'll figure out what that means in just a minute, okay? So we are going to practice graphing. We have graph y equals 1 over x minus 3 plus 2. So first of all, let's check our a value. So our a value is positive. We'll use that in just a minute. And now we need to look at our vertical and horizontal asymptotes. So to find the vertical asymptote, we are going to set our denominator x minus 3 equals 0. So whatever makes the denominator 0 is the asymptote. Okay, so you can put a dashed line at x equals 3. Now, if the denominator is a quadratic, you're going to have to factor that, and there might be 2 asymptotes, vertical asymptotes. Okay? To find the horizontal asymptote, we go ahead and compare our numerator and our denominator. So I compare 1 over x minus 3. Now, if there is no x, this actually has a degree of 0. And this, because there is an x but no exponent, has a degree of 1. So we know m is less than n, our numerator is less than our denominator. So y equals either 0 or our k value. Now we do have a k value. So our horizontal asymptote is going to equal 2. So y equals 2 is our horizontal asymptote. Now we know since a is positive, it's going to look like this, where it's top right, bottom left. You could just kind of sketch it in, but I think it's good to go ahead and have a little table that we draw just to understand what's going on. So I make an XY table, and I know that 3 cannot be a solution. An asymptote cannot be touched. So 3 is not a number I'll plug in, but I will plug in numbers around it. So 1, 2, 4, and 5. And then I put those in my equation. I'm going to come down here a little bit. I have y equals 1 over x minus 3 plus 2. And then I just trade out this x. So I put a 1 in. 1 minus 3 would be negative 2. So negative half plus 2 is 1.5 or 1.5. I keep plugging information in. I'll plug in 2. So 1 over negative 1 plus 2 is equal to 1. And then you can keep trying those if you'd like. When you plug in 4, you get 3 for y, and when you plug in 5, you get 2.5. Okay? Now, I'm going to plot these points just to make sure where I thought it would be is good. So I go over 1, up 1.5. I go over 2, up 1. And then I can kind of sort of sketch it in. We didn't really have a ton of extra information, so it's still a pretty rough sketch. But it gives us enough to know what side of the asymptote it is on. And then we draw it in, like so. Okay? Now we are asked what our domain and range is. So our domain is what x values can this cover? Well, you can tell that it keeps going for infinity to the positive x and infinity to the negative x. So it's all real numbers, except we will never touch our vertical asymptote. So it's all real numbers except when x is equal to 3. X cannot equal 3 ever because it can't touch the asymptote. And then for the range, we're looking at y values, so up and down. you notice that it goes forever infinity in the positive and forever infinity in the negative direction. So it is all real numbers. But we cannot have y equal to 2. We can't have y equal to 2. We never have a y value of 2 because it's the asymptote. Oops. Now, if you look up here, you'll notice these are actually the same as the asymptotes. They just cannot equal those things for the domain and the range. Okay, let's try another one. So, first check. Is A positive or negative? Well, A is negative here. So we know we'll switch it up and our graph will look more like this. And then we find our asymptotes. Now, for the vertical asymptote, you just find where the denominator is equal to 0. Now this one's pretty easy because you don't have to solve. X just equals 0. That is your vertical asymptote. You can draw it in. For the horizontal asymptote, we have to check our m and n again. So m is 0, n is 1. So once again, we have m is less than n. So this means that our horizontal is y equals 0 this time because there is no k term. So our y equals 0 is our horizontal asymptote. So it's actually just both the axes in this case. And then, if you wanted to, you could just sketch a simple graph. You know it has to be on this side because of our negative a. But I'm going to also make a table here again. So we have x and y. I know I cannot have 0 for x, so I can plug in -2, -1, 1, and 2. And when I plug that in, I get 2, I get 4, I end up getting -4 and -2 as well. So I'll plot those. This one's a little different than our previous problem. I'll notice our numbers are bigger. And there you have it. Now we do have to find our domain and range. So our domain, once again, it's all real numbers. It continues forever and ever, positive and negative infinity in the x direction, except when x is equal to 0, y is similar, travels forever in the positive and negative direction for y. So it's all real numbers except y cannot be 0 because of our asymptote here. Okay? Now, I did say I would show you an example of this sort of problem. When m is equal to n, what does it mean by y equals a over b? Oh, also I wanted to show you this, hopefully. Oh, we'll type it in again. Here is how you can check your problems. So if you want to go to Desmos or grab a graphing calculator, you can check to make sure you graphed your problems correctly. So the red one is our original problem, number 1, and the blue is our number 2 problem. You can go ahead and check those, even find points along it. Make sure you're good to go. Anyway, I'll show you the m equals n now. Okay, so here is an example of when our m and our n, the degrees are the same. In this case, they are both 1 and 1. So it says y equals a over b. But we don't really know what they're meaning there. Just meaning the coefficient in front of your term that is the degree is what a and b are. So when they are the same, you're going to look at this 4 and 2. So y is going to equal 4 over 2, or y is going to equal 2. And if you look here, that horizontal asymptote is at y equals 2. So that is how you can find those. All right, that's it for today. Have a good day.